Hello guys, my name is Ayush Agarwal. I will be your host today for upon discussing upon the topic about scanning probe microscope. Well, of course, it's a type of microscope that works on the principle of probing. So, first of all, we understand the word scanning and microscope, right? We will be discussing first of all like what is probe, what actually is probe. So basically, a probe is a blunt-ended cantilever tip or instrument used for exploring the part of a specimen. What's a cantilever tip, if you ask? It's basically a rod that is being fixed at one end and is being freed to the other end. So this is our on the as we can see on the right hand side, it is our probe which is being magnified about 1,000 times. It's intriguing to know that for scanning probe microscope or SPM, it's about one atom thick. That means it's about thinner than the needle that we use for sewing things. So moving ahead, we will be discussing about the scanning probe microscope. Well, a brief history of microscopes. The first optical microscope were discovered around 1600, and it was soon realized that it has a limit to observe the specimen. Why? Because the objects that were smaller than 0.275 micrometers, they become blurred and distorted due to various reasons like diffraction of light beam and atomic interaction with the photon of the light. So later on, upon further development of microscope, electron microscopes were discovered, and much later on, in about around 1980s, scanning probe microscope were discovered that were being more efficient than the electron microscope. So as we can see on the left hand side, we have got this simple image of optical microscope and this complex image of our scanning probe microscope. So basically the founders that are being acknowledged are respective Gerd Binning. This left one is Dr. Gerd Binning and the right one is Dr. Henrik Rohrer, that are being acknowledged for be the founder of the scanning probe microscope. So we will be discussing about how the scanning probe microscope actually work. Well, basically this cantilever tip is actually dragged or scans the specimen that is being put upon this specimen specimen tray. The probe basically scans it, and since the probe is one atom thick, there is atomic interaction between the surface atoms and this probe. So these interaction could be repulsive or attractive or no net force, depending upon the nature of force acting upon it. And these minute deflections are being actually scanned by computer. So this deflection, as we can see, this laser is being reflected upon the cantilever tip. So basically, as the tip is deflected, there is reflection in this light beam, laser light beam. So basically, this reflection is what we are measuring as a function of distortion to the atomic interaction. So computer actually interpret the data in the form of two-dimensional grid of data points and display it as a computer image. It's important to know that the image is inherently colorless. Why? Well, because we are basically measuring the properties of the atom rather than the reflection of light. And basically the images are later colored by the respective computer software. So on the left hand side, we could see the scanning probe microscope or SPM image of sodium chloride atom. Not atom, layer of sodium chloride, a surface. So moving ahead, yeah. So this is our visual representation of scanning probe microscope. As we can see, this is our probe chip that is one atom thick, and it's scanning the specimen atom by atom. It's important to know that the probe actually scans the specimen one atom at a time. So it is scanning the atom one at The probe is scanning the specimen atom by atom, and this highlighted area is actually the interaction. So basically we are measuring the interaction between the probe and the atom. So moving ahead. So every microscope has got some sort of advantages and disadvantages. Some of the respective advantages of the scanning probe microscopes are that it is not limited by diffraction like the electron microscope and the optical microscope. We know that light gets diffracted, so do the electrons due to their wave character, but it is not so in our scanning probe microscope. And unlike electron microscope, specimens do not require a partial vacuum but can be observed at STP, basically standard temperature and pressure, while submerged in a liquid reaction vessel. Well, as we know that electron microscope required a very specific condition. They should be, the specimen has to be put inside a vacuum, in a partial vacuum and under specific pressure and temperature, but this is not so in our scanning probe microscope. So we will be discussing about the disadvantages. The major disadvantage is that it's really time taking. Since think about it like that the specimen, we are scanning the specimen one atom at a time, right? And let's say if we are scanning the specimen, 1 mole of specimen, right? So it basically has 6.02 into 10 to the power 23 atoms. So it will take, of course it will take a very large amount of time, and it's not useful for examining buried solid solid or liquid liquid interface interactions. And moving ahead, so we will be discussing about the modes, scanning probe microscope modes. So what's a mode? Well, mode is like application or basically a function of microscope. Like we have got our cell phones through which we could call someone or message someone or play games. So basically this calling function, this messaging function, and this gaming function is basically a mode of a cell phone. Similarly, in microscope we have got two modes: contact mode and tapping mode. In contact mode, we doesn't interfere with the cantilever tip. It is basically kept at a constant external force, and it basically measures the interaction between the surface and the cantilever tip. And for tapping mode is basically used for imaging of a soft surface in which the cantilever tip is oscillated through a function generator. And moving ahead, so basically we are going to discuss about the types of microscope. It's in the previous slides I have discussed that we are measuring the interaction between the atom and the specimen. So what are these types of interaction? Well, this could be electromotive force, magnetic force, or basically a current between the tips. So basically we are classifying the microscope upon the types of interaction that we are measuring between the cantilever tip and the specimen. So we have got atomic force microscope that basically measures the electrostatic force between the cantilever tip and the sample. The magnetic force microscope that measures the magnetic force between the cantilever tip and atom. And of course, scanning tunneling microscope that basically measures the electric current flowing between the cantilever tip and the sample. So on the left hand side we have got our scanning probe microscope. As we can see, this is our horizontal axis upon which this sample tray could move, and it could actually rotate also, so basically covering the whole area. So moving ahead, well, the most important thing that I find regarding this discussion is what is the use, why are we measuring such small things? Well, of course, to increase our knowledge regarding the subject and also to discover new things. You will be surprised to know that Nobel Prize has been won on the back of these instruments. Basically, very fine and small particles are being found and are being made through these microscopes. Basically, they are used for misfolding diseases like Alzheimer's, Parkinson's, and Huntington's disease, diabetes, and of course tuberculosis. So moving ahead, we have got some visual images of our scanning probe microscope. This is our NaCl sample, and as we can see, there is small highlighted areas here. Well, basically they are impurities that are being present in the NaCl specimen. And this is one of my favorite image. It's of graphene, that is basically a 2D graphite. And this is our black and white image of copper atom, copper surface actually. And this is our propylene before and after treatment of corona. This is our atomic resolution of an gold atom. So it's really fascinating, and it's kind of hard to digest that these kinds of microscope are really expensive. It's about, the average price of these microscope is about $100,000. So on the right hand side we have got some more visual image of scanning probe microscope. If you want to follow up through my research, so these are the links. The following links will also be provided in the description section. So thank you, and hopefully you enjoyed the slide. I will be covering I will in future I will be coming up with new exciting slides as well. um, so enjoy, have a nice day. We will meet soon again. Thank you.